Okay, transducers. Okay, I told you before you have two transducers on this unit, P1 and P2. Okay, now the transducers are installed on the suction line and the discharge line of the compressor. Transducers have a sensing range of 0 to 620 psig. The connection points of the PCM are labeled P1, P2. The two connection points are identical, and either pressure transducer can connect to either input. The software in the PCM detects which transducer is connected to which input and assigns the signals accordingly. So we can get a couple faults here. Each transducer is going to have three wires, a ground, which is black, power, which is red, and a signal wire, which is green. Pressure in the system is converted to an electrical signal, and the board and software can interpret that signal. Okay. You got several faults, 5701 and 5741. That's a P1 open or open lockout. 5801 is P2 open fault, and 5841 P2 open lockout. Okay. 5702 is shorted fault. 5742 P1 shorted lockout. 5743 P1 sensor lockout. Okay, and we do have the same 5802, 5842, 5843 for the P2. All right. So several different transducer faults that can occur. Now, the biggest thing with the transducers is confirming what the unit is seeing compared to what you see with your gauges and your meters. Okay. What I would do if I'm troubleshooting a transducer issue is I'm going to look on the user interface and I'm going to see, what does it tell me the discharge pressure is, right? What does it tell me on the user interface? And then I'm going to compare that to the app. What does it tell me here? Discharge pressure, okay, suction pressure, that sort of thing. This stuff needs to make sense to the control. If the control is seeing a pressure that does not make sense, then you may get a fault listed before. Okay, so very important to compare what the unit is seeing to your readings. Okay, that's really the easiest way to troubleshoot these transducers. Now, there is a output function graph. You will not find this graph in the manual. Okay, so you can use it here. Remember, it's a 5-volt DC being supplied to the pressure transducer. So let's say I've got a voltage of, I don't know, call it 150 psig. So I'm going to go right here. That's give or take around this area. Okay, and I'm going to follow it over to the left. So what would you say? 1.3, 1.35, somewhere in there. So I should have 5 volts DC to the sensor and getting back around 1.3, 1.35, something like that. Okay, that's at a pressure of 150. Okay, as the pressure changes, then your voltage is going to change as well. Okay, troubleshooting allow some variance, but they should be reasonably close. Okay, like I said, red to black, that's power to the transducer. Black to green is your voltage coming back. So you can use your thin meter leads, okay, and get in behind the plug while it's connected. Okay, you see here red and black. You should have 5 volts DC. We can read 4.9 on the meter. Okay, and then something less than 5 volts DC coming back between black and green. Okay, in this case, when I took the picture, when I took the measurement, was 2.41. So if I want to know what pressure that is, I can come back here Here's my 2.41, give or take. So I was probably somewhere in this area, almost 300 PSIG. Okay. Now you can read these voltages with the unit, in standby. The unit doesn't have to be actively running for you to read these voltages. Okay. In fact, a lot of times I'll have guys go to the user interface and just take a look at the status screen and see what is the unit doing right now. Yeah, the unit's not running, but it's still going to be reporting a pressure. Okay. Um, so let's see. The expansion codes 01 and 41 explain the type of issue. In that case, it was an open, okay, meaning the signal wire is returning more than 4.5 volts DC. Most likely the cause is the sensor wire being disconnected and the PCM board is pulling up the voltage signal to supply 5 volts. Okay. Expansion codes 02 and 42 indicate that it's a shorted, meaning that the signal wire is returning less than 0.5 volts DC. When the DC value of 4.8 to 4.9 is returned to the PCM, it will trigger the 5743 and 5843 faults. Most likely, it's a failed transducer. Switch the harness from P1 and P2 and see if the malfunction follows the transducer. Okay, so yeah, you can take P1, I'll back up a little bit, P1, P2, right? Pull this one off and put it on the other side. Pull this one off, put it on the other side. Okay, and look on the user interface or on your app. Does the pressure issue follow the transducer, or does it stay, wherever it is? So let's say I had an issue with my suction pressure. Okay, and it doesn't matter if it's P1, P2. My suction pressure is reading incorrectly. I pull P1 and P2 off the board, I swap them, plug it in, and then I look at the user interface. Now, is it a discharge pressure issue or is it still a suction pressure issue? Okay, if it's still a suction pressure issue, then that means the problem stayed with the board. Okay, I switched to transducers and the problem did not follow the transducer, it stayed with the board. Okay. Now, I will tell you, this can get a little tricky in doing this because the software in the board assigns the transducer. Okay, so I guess it's kind of hard to explain without actually showing you, but let's say I had two transducers. One of them read 100 PSIG and the other one read 300 PSIG. Okay, once I plug those into the board is going to say, hey, the one that's reading 100, that's suction, and the other one is discharge. It doesn't matter if they're actually connected to suction or discharge, that's what the board is going to assign. Okay, and it assigns it based on what the pressure is. It makes sense. If it's 100 PSIG and the other transducer is 300, well, yeah, the 100 must be suction, right? Well, it may or may not be. Okay, so that's where we as technicians come in and we have to really try to identify what is what here. So you can check your voltage. Am I getting the right voltage out of the board? Am I getting the right feedback from the transducer? Okay, compared to your voltage chart. I will tell you, I had this happen a couple times, I think twice in the last couple years. If you look at the picture on the right, this is how the transducer should be wired from left to right, red, green, and black. Okay, red, green, and black. The one on the left, you can see there's a difference. We have red, green, and black, and then green, red, black. Okay. This particular issue, the unit ran for almost a year before the issue was caught. Okay, so issues like this can be hard to see, but like we say down here, look with your eyes. All right, The gentleman that found this had changed the transducer. He changed the board. I think he was going to change the transducer again before he realized, hey, let me call tech support and find out what's going on here. This is what we found. Okay. So, you know, a peculiar issue. And like I said, I've had it happen to me twice in the last couple of years. So it's not like a super common thing, but something that you really have to look for. If you got something that you're scratching your head and you're just not sure, and you're thinking, well, let me call tech support, that's fine. But you can also look with your eyes first and see, is this wired the way it should be? Okay. So what did he do? He swapped the green and the red wires in the harness, and units running like a champ. Okay. So just look with your eyes. Look with your eyes. Okay, 3215 and 3255. It's compressor low suction shutdown and compressor low suction lockout. All right. It's looking at the transducer. Okay, the transducer takes place of the pressure switch. So there is no pressure switch. It's just the transducer reporting, hey, we got low suction. So if I had this fault, what I would do is look at my suction pressure on the app or on the UI. Okay, you can see here suction pressure 135. All right, when I connect my gauge, is it reading reasonably close to 135? If I read 137 on my gauge, okay, I'm happy with that. Now if I read 200 on my gauge, well, that's a problem. But as long as it's reasonably close within a couple psi, then you should be fine. Okay, but there are soft and hard low pressure limits in code 3215. The low pressure limit can be exceeded up to 2 minutes before the code is generated, while exceeding the hard limit results in an immediate 3215. Okay, the low pressure limits are compressor and RPM dependent, but typically 30 psi and 15 psi are what you're going to see. 4 occurrences of 3215 in a 2-hour period will give you, or I'm sorry, 4 occurrences of 3215 period will give you a 2-hour lockout. Active envelope management attempts to mitigate the low pressure by adjusting the system operation. Remember, we had the 1811, which was freeze protection. Okay. When the freeze protection occurs, it starts to back off the RPM, slow the compressor down. That's going to bring the suction up. It does the same thing with 3215. If we're hitting that low limit, then it's going to back off the RPM of the compressor. It's going to bring that the suction up, and it's going to try to ride through it. Eventually, it may get to the 3255 and lock the system out. What causes low pressure in a system? Okay, blockage in the liquid line filter dryer, stuck TXV, stuck EXV, no airflow or low airflow across the evaporator, low charge, low ambient temperatures. If you're trying to run the system in cooling and it's pretty cool outside, that's going to increase the sensitivity to some of these issues. Okay, remember the pressures follow each other. So if I've got a low ambient temperature, my head pressure is going to be low. Corresponding suction pressure will be low as well. Okay, so that could increase some sensitivity to these lockouts. Check your pressure and temperature difference of refrigerant lines at the condensing unit compared to the fan coil or the furnace coil. Maybe I've got excessive pressure drop in my liquid or suction lines somehow. Okay. So, if you got a metering device issue or you suspect a metering device issue, confirm your airflow first. Okay, that's refrigeration troubleshooting 101. Check your airflow first, then your components. Okay. We added 3259 here. So let's see, 3259 is triggered when the suction pressure is too low to safely start the compressor. All right, so refrigerant saturation pressure is low enough, the system will be inoperable until pressure increases to an acceptable range. What could cause that? No pressure in the system. You know, maybe there's a leak, a large leak, and it leaked all the refrigerant out. There you go, 3259. Okay. Could it be a transducer issue? Sure, but you'll probably have some transducer faults with that. Okay. But if you're getting immediately 3259, throw a gauge on there. Okay. And then look at the UI, look at the app. What is it reporting to you there? Look at your gauge. What do you have there and compare? All right. 3116 high pressure shutdown and 3119 high pressure disable. High pressure switch opens at 670 psig. 3116 should never occur because the discharge transducer high limit is much lower than the high pressure switch trip point. If you have an active 3116, inspect the wiring of the high pressure switch. You can see the high pressure switch here. Check your wires, make sure your wires are not pinched. It goes back to the VFD. You know, make sure that the plug at the VFD is secure, that the wires are in the plug properly. Okay, again, 3116 should never occur. Your discharge transducer should shut the unit down first before the high pressure switch trips. Yeah, loose connections, electrical short could cause the fault to appear. Check for wire rubouts, wire passing through the electrical cabinet, you know, possibly getting pinched, that sort of thing. 3119 is high pressure disable. It's triggered when the discharge pressure is too high to start the compressor, over 620 psig. Okay, if the fault is active, you will most likely have other fault codes occur, such as 3813 and 4413, which is a high pressure differential start disable, and a 4413 is PEV timeout. We'll talk about those shortly. If that fault is active, you know, again, connect your gauges, okay, see what you have, and look at the UI, look at the app, see what it thinks you have. Okay, you could have a problem with the transducer. You could have an issue with the pressure equalizing valve. Remember, pressure equalizing valve should be opening before and after a cycle. Okay, so those are some things to check. The equipment will not operate while this fault is active. Okay, here's another look at your high pressure switch. Okay, the wires come into this plug and you want to check this plug. Okay, check the plug at the VFD. Make sure the wires are seated in the plug. Make sure it's making a decent connection there. Okay, if you are not making good connection, you could get a 3116. Okay, continuing on, 3119 high pressure disable. Look at the UI, look at the app, and find out, you know, what are my pressures, and connect your gauge. What are my pressures on my gauge reading? Okay, do we actually have a high pressure condition? Okay, that's not allowing the compressor to start. So confirm what the system is seeing. Right? Discharge temperature, discharge pressure. 3111 and 3158. This is compressor high pressure limiting and compressor high pressure lockout. So the high pressure limit is based on the compressor model and varies with operating speed. Okay, when this fault occurs, the system will shut down and restart after a 5-minute delay if demand is still present. Each time the fault occurs, the maximum allowable compressor speed will be reduced by 25% until the minimum is reached. Okay, so the goal behind this is to keep the compressor operating in the envelope within limits. Okay, it's trying to maintain operation the best it can, but it's not going to allow the compressor to drive itself into the ground. Okay, each hour of compressor operation without a fault will increase the compressor speed limit by 25% until it can get back to 100% of operation. Okay, 3158 occurs when the compressor the high pressure limit is reached while the compressor is at its minimum operating speed, and then you get a lockout for 2 hours. So you get to 3111, okay, it ramps down. Let's say you're at 100%, you ramp down to 75, ramp down to 50, and you're down at 25%, which is the lowest. If you have to ramp down again, then you're going to go to 3158 and you're going to get the lockout. Okay. Visually inspect the equipment. Okay. What could cause high pressure in the system? Dirty condenser coil, lack of airflow across the condenser coil, condenser airflow recirculation. Okay. Extreme temperatures, sun loading, refrigerant circuit blockage, plug dryer, EXV, TXV issue, refrigerant overcharge. I've seen that a few times lately where guys have a low suction pressure. So they try to compensate by overcharging the system. Well, then they kind of make two problems for themselves. One, they got the low suction to begin with. Now, two, they have an overcharged unit. So, you could have some issues like that as well. But again, it goes back to what is the unit seeing compared to what you see with your gauges. Okay. 3818 is a high differential pressure start disable. This is an interesting code. I've seen this happen maybe once or twice. When the compressor is attempting to start against high pressure, it can result in start failures. The pressure equalizing valve is included to ensure the compressor will never start against high pressure differential. The fault will become active if a demand exists and the PEV is not successful in lowering the pressure differential below 100 PSI. All right. So the first thing you want to do is connect your low and high side gauges and then look at the UI, look at the app and see what do my pressures show on here and what am I actually seeing on my gauges. Okay. The fault will clear and the unit will start normally once the pressure differential is below 100 PSI and the demand is present. So if the unit is off, right, in a standby mode, and your suction reads 100 and your discharge reads 250, it's not going to start. The differential between those two is about 150 PSI. So that's what it's telling you, high differential pressure start disable. What it's going to try to do is open the pressure equalizing valve. It's going to try and open the valve for 10 minutes. If the valve continues not to, reduce the differential, then you're going to get the high pressure differential start disable. Okay. Again, looking at the app, looking at the UI and comparing it to your gauges will be critical to troubleshooting this fault. Okay. The equipment's not going to operate while this fault is active. Okay. You may also see a 4413 PEV timeout or 6201. It's kind of unrelated, but the PEV timeout you will usually see with your high pressure differential start disable. And at least a couple of times I ran into this code, we had an issue with the transducer. The transducer was reading incorrectly and the system saw a high differential and it would not allow it to start. Like I said, the PEV will open and it will try to reduce the pressure differential. After 10 minutes, you're going to get the PEV timeout if the pressure differential has not been reduced. Okay. So let's see, PEV opens for 2.5 minutes, or it opens 2.5 minutes after the compressor shutdown if the pressure differential is between 200 and 300 psi, or if the pressure differential is greater than 50 and a demand is present. In both cases, the PEV will open until the differential is less than 40. You get 4413 when the PEV is open for 10 minutes and it does not reduce the pressure differential below 40. According to the manual, it says if this occurs, it's likely that the valve or the coil has failed. Replace the PEV and harness first. If the fault persists, replace the PEV valve itself. I would caution you at jumping to that conclusion with this fault because the couple times I have seen it, it's been related to a transducer. Okay, so you know what I've found with troubleshooting this unit is these fault codes are very descriptive and they do help you narrow it down, but you want to look at everything as a whole. You don't want to say, okay, I got 4413, the manual says change the PEV, that's what I'm going to do. You want to stay away from that train of thought. Okay, you want to look and see what fault codes do I have in addition to 4413, and do they correlate to each other at all? Because that can give you better guidance to find out what needs to take place next. Okay. Most of the time, you're going to have several faults together. You're not going to have just one fault happen at a time. You're going to see maybe 2 or 3 faults happen together. And then if you look at the information for each fault, that can give you a little bit better guidance. Okay. 6201 is a PEV solenoid open. That's pretty easy, right? The solenoid is open. Is it really? Okay, let me ohm the solenoid, excuse me. So let me ohm the solenoid, right? I'm gonna zoom in here so you can see I got 2 meter leads on the plug. That's my pressure equalizing valve wires there, 12.93 ohms, okay? That's not K ohms, that's just ohms, okay? So 12.93. So give or take 13 ohms, right? If you read OL when you put your meter leads there, then hey, well, I got an issue with the solenoid. I would check the wires, of course, get the solenoid in your hand, physically look at it. Is it hot? Is there some reason why it opened? Maybe a wire got pinched, okay? But the equipment will not operate while that fault is active. 4113 defrost timeout, 6153 reversing valve timeout lockout, 6113 reversing valve timeout fault, and 6141 reversing valve open lockout. This applies to heat pumps only. Okay. The 4113 is a defrost timeout. After the predetermined length of time at a possible coil frosting condition must be below 35 degrees, defrost will be initiated. Coil temperature is monitored and will complete defrost cycle once it reaches a target value dependent on the model and the outdoor air temperature value. The code will be active when defrost is terminated on maximum time and the target coil temperature has not been reached. Okay, so typically when a defrost occurs, it's after a certain amount of runtime and the coil meets a certain temperature, you go into defrost, and then it should be terminated on temperature. Once the coil gets above a certain temperature, then it's going to terminate. Defrost is an inefficiency. It is absolutely required for heat pumps, but it's inefficient, okay, from a energy conservation standpoint. When you have to terminate defrost based on time and you still didn't meet the temperature, that's when you get the 4113. defrost timeout, which means your defrost took too long and you did not bring the coil temperature up above the threshold. It's going to go back into heating, but you're going to get the 4113 and it's going to tell you, hey, we defrosted and we didn't do our job. Okay, so it's just alerting you to what's happening. If that happens, extreme ice on the outdoor coil, probably pretty rare in our area. Coil's temperature sensor not properly attached, probably something that's more likely, or the coil sensor is reading incorrectly, possibly. Okay. The reversing valve only actuates when the pressure difference between the suction and discharge of the compressor is above a minimum level. Okay, so you get the 6113 is set whenever the minimum pressure condition prevents a reversing valve to switch for 10 minutes. 6153 is set when 6113 has been declared 4 times in 2 hours. The 6153 results in a 2-hour lockout. When the fault occurs, it may be due to a reversing valve being stuck between heating and cooling positions, or the compressor is not pumping properly. Compare suction and discharge pressure on the app and the UI, and if the pressures are reading correctly, continue troubleshooting the valve. Troubleshooting your reversing valve, right? Checking temperature difference across the valve. Okay, you see this is not a variable speed unit here on the right, but it's a reversing valve, and troubleshooting a reversing valve is the same no matter what unit you're in. Okay, so you want to check whether you're in heating or cooling. You're going to, in this case, if I'm cooling, this would be my suction line. Okay, and I'm sorry, this is actually troubleshooting heating. So this is my discharge line. Okay, and this is going to my coil. Okay, so I'm sorry, I misspoke again. Trying to get a little too fast here. Basically, you want to check temperature difference across the valve, okay, whether you're in cooling or heating. It's important to remember the single pipe on the reversing valve is always discharge, and the one in the middle of the 3 is always suction. Okay, what changes are the other 2 pipes. Okay, so whether you're in cooling or heating, you want to check the temperature difference across the valve. Okay, it's important for you to know what cycle you're in when you're taking the measurement. In most cases, you're going to want to have 2 clamps. Make sure the 2 clamps are accurate and that they read the same. Okay, here we can see this is in cooling cycle. So I would read discharge right here. And then the line down there at the bottom is discharge going to my condenser coil, which is over here. All right, so I hope you guys are following me there. I did misspeak a few minutes ago. So check your temperature difference, right? In theory, you should have give or take 5 degrees. In reality, you may see upwards of 8, 9, maybe 10 degrees. I wouldn't like to see 10. I would prefer it to be under 10 degrees, but you know, if you did see that, it could possibly be okay. All right, but you're going to want to check the temperature difference in cooling and in heating so you can see, is there a large difference? One thing to remember is your meters, your tools, right? If you look here, this is a brand new meter, brand new temperature clamp, and the other one is a little older, obviously. I mean, if they both read the same, you know, that's great. Okay, but don't always take your instruments at face value. You want to test them periodically. Okay, in this particular picture, these are my temperature clamps. I've used these temperature clamps for a long time. I had one fail, which is why I bought a new one. And you can see this one's brand new. Now, what I would do periodically is take my temperature clamp it onto a piece of ice, and stick it into a cup with ice water. and then look at my meter and see, does it read 32 degrees? Okay, it should be at 32 degrees at sea level, which we are at sea level. Okay, if I'm testing my meters regularly and I am confident they are reading properly, then I've got no problem using a new and old meter because I am testing it regularly and I make sure it works. But if I buy it brand new out of the box and I plug it in without testing it, you can get into trouble. I've bought brand new temperature clamps, clamped them on some ice, stuck it in ice water, and read 35 degrees. Okay. Now, for me, I have to take into account now 3 degrees extra every time I measure a temperature. Okay. So some meters you can calibrate, some you can't. You got to know your tools. All right. um, Kind of got away from some of the faults here, but 6141 senses that the reversing valve coil is open or an infinite resistance and it's not operational. Okay. Ohm the coil. You can see here, ohming the coil. What's it supposed to read? Well, this was a 5-ton unit, give or take 14 ohms, plus or minus maybe an ohm or two. Okay. 6441 EXV for heating. This is a phase open lockout. 6444 and 6445. That's the power shorted lockout and phase shorted lockout. This applies to the heat pumps only because you have an EXV in heating for heat pumps. Okay. You can see the plug here on the left. Okay. 5 pins. This diagram is out of the manual. You got a couple different phases there. The EXV coil resistance should fall between 43 and 49 ohms when measured from common to any one of the remaining terminals. Okay, so you can see here, gray in this case is your excitation, which is common. Okay, and then so from pin 1 to 2 or 1 to 3, 1 to 4, 1 to 5, you get it. You should have somewhere between 43 and 49 ohms. 6441, the phase open lockout. So each time power is applied to the outdoor unit, the EXV will operate to a known position, as the valve does not have the capability to provide a feedback on the actual position. So what the PCM software is doing is driving it to a known position and then keeping track of it. Okay, so if it drives it all the way to, say, position 1, and then it opens it up to position 50, okay, it keeps track of that. If it has to adjust it to position 25, it keeps track. So it keeps track of it. So anytime power is applied, it has to drive it to a known position and then keep track and remember, where is it at, because it will not provide a feedback. So the 6441, the code occurs when the PCM determines the resistance of the stepper motor coil circuit is above the maximum value to properly function. All right, so then you would disconnect the plug, check the wires, make sure they're seated in there, check the wires going to your stepper motor, and then ohm those wires. Okay, it should be between 43 and 49 ohms, plus or minus 10%. 6444, the code occurs when the PCM determines the EXV power supply is drawing excessive current. Most likely cause of the fault is the wire attached to pin 1 is shorted to ground. Inspect the wire, harness and plug, and ohm it to ground. Find out if it's actually shorted to ground. Okay, you should have OL if you're ohming to ground. 6445, the most likely cause of the fault is one or more wires attached to pins 2 to 5 being shorted to ground. Okay, so again, confirm, look at the wires, make sure they're connected, make sure they're not pinched, ohm them out. Go from pin 2, the black wire, we're going to go to the ground lug in the equipment. Okay, and do we have continuity there? Am I reading an ohm value? You know, if I go from pin 2 and I use ohms and I go to the ground lug in the equipment and I read, I don't know, 5 ohms, I'm shorted. Okay. So EXV troubleshooting. Another way you can troubleshoot this valve, go into refrigerant charging in the advanced menu, go to EXV position and take a look at it. Hey, I've got EXV position, open and close. You see the suction pressure, you see the EXV position. You can actually drive this open and closed, and you should see a corresponding suction pressure change. Depends kind of on exactly when you do this. You know, if the unit is, say, in a standby mode and, you know, pressures are equalized, you're probably not going to see too much pressure differential. Okay, so it really depends on when and how you do this. Okay, but you can physically drive the valve open and close. You should see some pressure change. 6541, 6544, and 6545 all have to do with the vapor injection circuit, the EXV. Okay, and this applies to the 5 tons only. Only the 5 tons have the vapor injection circuit. So EXV is required to operate the vapor injection circuit when it's used in high demand situations, such as high ambient cooling or low ambient heating. Once a day, the EXV VI will test itself by operating to a known position. The valve does not have the capability to provide a feedback. Okay, just like the heating EXV. Okay, it looks very similar. It is still 5 wires, but notice on the plug, you have 6 pins, although 1 pin is left blank, so you cannot interchange them. Okay, now the EXVs are similar, but they are not interchangeable. So if I have a heating EXV, I cannot put it in place of vapor injection and vice versa. Okay. 6541 occurs when the PCM determines the resistance of the stepper motor is above the maximum value. Okay. So very similar to the other faults for the heating EXV. Okay, 6544 occurs when the EXV power supply is drawing excessive current, and 6545 occurs when the EXV power supply is drawing excessive current, okay, in pins 2 to 5. So with 6544, this is going to be pin 1, and 6545 is pins 2 to 5, drawing excessive current. We have a handy chart for you. Okay, so you can see the coil resistance, all right, and your excitation, which is going to be your common. So then you would ohm 2 to 3, 2 to 4, 2 to 5, 2 to 6, okay, etc. Pretty straightforward. Condenser fan motor. I got some general info for you here. Okay, this is the 4 and 5 ton equipment. And the picture on the right is a 2 and 3 ton equipment. It's basically the same. The plugs look a little bit different. You can see it's just the physical nature of the plug, but the wire colors are all the same. Now, the fan connections are the same, right? But the fan motor on these units have 5 wires, and it's 240 to 373 volts DC. You have red on a single plug, and then black, white, yellow, and purple on a separate plug. Okay. There is also an intermediate harness between the VFD and the fan. Okay. And I'll show you a picture here. If you look on the right, you can see the 2 plugs. Okay. The wires come through a choke, and then they go into this plug here. This is the actual fan motor here, and it goes to the fan motor that way. Okay. So we have an intermediate harness from the VFD, okay, to this point right here. Personally, I don't care for that. That's just another connection point that to me is something else to fail, but over the last couple of years, I don't think I've had any real problems with the intermediate harness, but I don't know. I didn't design the unit, it is what it is. But just so you're aware, there are some color differences. You see here red, yellow, black, white, and purple. And then when we look closely here on the left, red, blue, yellow, orange, and black. Okay, so there are some color differences. You always want to check those connections, make sure you're making a solid connection, and make sure there's nothing compromised in that intermediate harness. Okay. Now, the fan motor winding resistance cannot be used because there are embedded electronics. All right. So it's not like a PSC motor. You can't just ohm this thing out and say, well, the ohm values, they kind of make sense. They don't make sense. So we have this chart here. This is a DC voltage, pulse width modulation, and ohm values. All right. So if you look here, VDC, okay, which is red, to ground. All right. In this case, the black is the ground. Okay. So if I'm checking voltage between red and ground, I should have 240 to 373 volts DC. All right. If I'm ohming it out, it should be 1.36 meg ohms. So that's 1,360,000 ohms. Okay. VCC is the orange wire. When checking it to ground, should be around 15 volts DC. And if you're going to ohm it out, 45.4 K ohms. So 45,400 ohms. VSP to ground should be 0 to 5 volts DC and around 115 K ohms. FG is a signal wire, a feedback wire. It should be around 1.5 volts DC. And if you're ohming it to ground, you're going to get OL. Okay. These are normal approximate readings. If your ohm readings and voltage readings vary differently, then concerning voltage, I would look at, what faults are there. If you have everything disconnected and you're ohming the motor itself, then you could have a bad motor, okay, or a failed motor, I should say. It's not bad, it's failed, okay. Now, couple fan motor faults, 3913 fan start fault, 3953 fan start failure lockout, and a 3914 is a fan speed error. Okay. One thing we need to remember is there is a replaceable fuse on these VFDs or inverters, if you will. Okay. If you get a 3913, pull that fuse, take a look at it and see. Now that's high voltage. Okay. So make sure you kill the power to the unit, check that fuse. All right. But when you have a demand for cooling or heating, on startup, the fan speed is commanded by the VFD. After 25 seconds, the FG wire, which is the fan speed signal feedback, if it equals 0, the PCM will reset the VFD and try to start again. After 3 VFD resets, code 3913 will be set and most likely accompanied by another fault, 8815 VFD reset. Okay, you actually will see 8815 accompany a lot of different faults because the VFD is being reset by the PCM. The PCM continues to reset the VFD up to 6 times, and then it will eventually declare 3953 and lock the unit out for 1 hour. A successful fan start will reset the fan fail start counter, and it will start all over again. If you're getting these faults, inspect the wiring, the connectors, look for damage, loose connections, overheated connections, check the fan blade, make sure it spins freely, check the external fuse. If no voltage, if no physical blockage is present and the fuse is not open, ohm the motor and replace it if necessary. Now, 3914 is a little different. You get this fault when the commanded speed is greater than 200 RPM and it differs from the actual speed reported to the VFD by more than 20%. So the fault is also declared when the commanded speed is 0 and the VFD is receiving greater than 80 RPM feedback from the fan motor. Most likely scenario, partial physical blockage of the fan blade, ice buildup, in rare cases, not around here, extreme coil blockage, bearing issues, high resistance to spinning, that sort of thing. You can also look at the RPM on the UI and the app, but you wouldn't really know what the requested RPM is versus the feedback. If the motor seems to be okay, ohm the motor, and you could have a VFD that is not reading the feedback signal correctly. You may need to troubleshoot the VFD in that case as well. 3915 unexpected fan shutdown, 3955 unexpected fan lockout, and 3958 VFD system lockout fan motor fail. These codes are a little peculiar, and the manual isn't very helpful at times, it seems like. 3915 is declared when the VFD commanded speed is above 200 and the actual speed is reduced to less than 80 RPM for 10 seconds. The fault triggers a compressor and fan shutdown and then a VFD reset. Other fault codes will be present. Okay. If the demand is still present, try to restart and run normally. An intermittent open in the signal wire, the FG wire, could cause this fault. So, check your connections, check your plug, check your intermediate harness. 3958 is originated in the VFD when the fan motor feedback is not received and the VSP value has been sent to the fan motor for 30 seconds. So basically what it's telling you there is it's telling the motor to run, and it thinks the motor is running, but it's not getting a feedback. The fault can also be set when the speed error between feedback and command is greater than 100 RPM. This fault should never occur because 3915 will be declared after 10 seconds. When this fault is active, the compressor and fan are shut down and the lockout time is 30 minutes. Here's where I don't care for what the manual tells you. It says internal electrical damage is likely causing the FG feedback to not be received by the VFD. Replace the fan motor first, then the VFD. To me, that's not definitive enough, but if you run across something like this, give us a shout and we'll try to help you out best we can. In rare cases, it's you've replaced the VF or you've replaced the motor, then the VFD, but sometimes you can get away with looking at what other faults are occurring. And like I told you before, there's other faults that could be occurring or will occur with this. And if we can try to eliminate some things as we go along, we might find out, hey, this is just the VFD or it's just the motor and not both. So 8411 and 8458, that's a VFD heat sink over temp fault and heat sink over temp malfunction. So I told you before, there are some internal temperature sensors to monitor critical power components of the VFD. All right. What we're looking at here is a IPM or PFCM temperatures. Okay, so here's your PFCM, here's your IPM. When these temperatures approach 200 degrees, that is when you will start to see some of these faults, 8411, 8458. All right, so you can look on your HP status of the UI. You can look on your app and you can see PFCM temperature, IPM temperature. Make sure they both read the same. These sensors are embedded in the VFD, so it's not like you can put a clamp on there and double check, okay? When the fault's active, the VFD will shut down the compressor, but continue to operate the fan to draw air across the heat sink. Try to expel any residual heat. Once the heat sink temperature is acceptable, the system will restart, but with a reduced demand. Much like the high pressure condition, it's going to reduce demand by 25% for each 8411 occurrence. After you get to the minimum, 25%, and you still have a VFD heat sink over temp fault, then you'll get the 8458, and it will be a lockout, 2 hours. Okay. Most likely the cause restricted airflow over the heat sink, recirculation of condenser discharge air, could be high voltage issues, connections. Check the connections, especially on the reactors. Inadequate contact of power components with the heat sink, not allowing the intended heat transfer between components and the heat sink. So, again, you look at all those things. Really, you can see some of that stuff with your eyes. Is it recirculating air? Is it dirty? That sort of thing. Okay. 8832 is VFD IPM temperature sensor fault. Basically, there is a sensor in the VFD. It's failed. The only way to fix that one is to replace the VFD. Okay, continuing with the PFC, 8113, 8153. PFC, by the way, is power factor correction. There are power factor correction circuits, and they involve the reactors. Here you can see a reactor on this unit. Okay, the VFD, well, the 5-ton units have 2 reactors, but I've seen cases where these plugs, okay, they get loose, and you will begin to have some of these PFC faults. Okay, if you have those faults, then check your reactor, check the plugs. Okay, these plugs, the other end, follow it up to the VFD, make sure that's a sound connection there. Okay. After 2 occurrences of the 8113, you will get the 8153 and lock out for 4 hours. A power cycle will clear the malfunction timer, but continued malfunctions indicate a high current situation. Okay. You could have VFD or compressor damage. You could have reactor damage. Measure the resistance of the reactor. If the measurement is OL, meaning open, then replace the reactor. Otherwise, replace the VFD. The reactor resistance should be low, but if you're reading OL, then replace the reactor. 8114, unbalanced power factor correction monitoring, and 8154, VFD system lockout, unbalanced PFCM. Okay. Kind of the same thing here. Most likely caused by a disconnected or faulty reactor. The VFD will shut down and attempt to restart. After 2 occurrences within 10 minutes, you get the 8154 and is locked out for 4 hours. Okay, check your reactors, disconnect, measure the resistance of both. It should be a low resistance. If it's open, replace the reactor. If it's a low resistance, you've checked all your connections, there's no signs of overheating, everything else looks fine, then you'll have to replace the VFD. 8834 and 8874, this is the VFD internal fault, PFCM sensor A, and the corresponding lockout. Kind of the same thing, 3 occurrences of the 8834 within a 4-hour period gives you the 8874. Let's see, while the fault is active, the unit is inoperable. Once set, it is unlikely to go away and indicates VFD damage. Again, check your reactors, check for signs of overheating, check your high voltage connections. If all of that seems fine, then replace the VFD. 8837 and 8835 and 8875. So you've got the PFCM temperature sensor fault, and then sensor B, PFCM sensor B. Again, kind of the same thing. 3 occurrences of 8835 within 4 hours gives you the 8875. Cycle power, see if everything comes back. Check your connections on your reactors. Check your, temperature in your UI. See what that is. Check your temperature on the app. See what it's telling you. Check your high voltage connections all the way up to the drive, the reactors. If all of that seems to be okay, then you have to replace the VFD.